So let's look at a couple more examples of graphing a circle when we're given its equation. And I've copied in the standard equation for a circle where the center is at an x value of h and a y value of k, and the radius we call r here. So using this standard equation, we can figure out the center and the radius of the circle. And remember, the general strategy is just to figure out which x value makes this expression 0 and which y value makes this expression 0. And you can see positive 5 would be h, since we're subtracting h, and positive 2 would be k, since we are subtracting k and we're subtracting 2 here. And the radius squared is what the equation is equal to. So in this case, the radius squared is equal to 16. So let's first write down our center. It has an h value or an x value of 5 and a k value or y value of 2. And then we know the radius squared is 16. And if we take a square root of each side, we can figure out that the radius is 4. So let's start by graphing the center of the circle and then using the radius to figure out the other points or the points on the circle. So it's at 5, 2, and for this coordinate axis, I'm going to use a scale of 2. So let's say that this is 2, 4, and 6, and we'll do the same for the y values. So the center is at 5, 2, right about there. And we'll use the radius. We'll go up 4 points and let's say to the right 4 points. So if we go straight up, we'll be at an x value of 5, but our y value will be at 6. And we know this is on the circle since the radius of the circle is 4. And now if we go 4 units to the right, we're at an x value of 5, so that will take us to an x value of 9. The y value stays the same since we're just going horizontally, straight right. And we could do the same for the left point of the center and the lowest point of the circle from the center by, again, just counting out 4 units to the left and 4 units down. And from here, let's draw a sketch of what this circle looks like. And remember that we're drawing this by hand, so this is not perfectly to scale. We would need some type of software to draw this more accurately, but this will give us a rough idea of what the graph of this circle or this equation actually looks like. And remember, to check your work, you can take one point that you know is on the circle that you found using the radial distance from the center point and plug it into the equation. And if you get back something true, you can feel more confident that this graph is correct. So we're going to check that 5, 6 is actually on this circle, and we're just going to plug it in. So x is 5, y is 6, so we get 5 minus 5 squared plus y is now 6 minus 2 squared, and this should equal 16. Well, this is 0 squared, so that's just 0. And this is 4 squared, and 4 squared, 4 times 4, does equal 16. So this point is on our circle, which means we can feel more confident that this is the correct graph. Now let's look at one more of these examples where, again, we're given the equation of the circle and we need to find its center and its radius. And remember that the x value that makes the expression here 0 is the x value of the center. So that would be minus 3. And the y value that makes this expression 0 is the y value of our center, and in this case it's minus 4. And the equation is equal to the radius squared. So r squared in this case is equal to 25. So that means our center is at the coordinate minus 3, comma minus 4, and the radius, r squared, is 25. So we can take a square root of this to find the actual radius, and the square root of 25 is 5. So we know the center, we know the radius, so let's plot that and see if we can draw a picture of the circle. And for this, we'll use a scale of 2 for the x and the y values. And so our center is at -3 for the x value and -4 for our y value. So somewhere about there. And we use C for the center. And our radius is 5. So let's go 5 units up and 5 units to the right. So we're at -4. So if we go 5 up, that brings us to -1. And our x value remains the same since we're just going vertically up. Now, if we go straight to the right, we're at -3. So going 5 right brings us to 2. And if we want, we can also go down 5 and left 5. But at this point, we can draw a sketch of the circle. So you can see we have the graph of the circle, which is drawn approximately. And we know this radial distance is 5, and we know the center, C, of this circle is at -3, -4. And if we want to check that this is correct, that these are actually points on the circle, this is at the x-coordinate of 2 and the y-coordinate of -4. So we can take this coordinate point, plug it into our equation, and if it simplifies to 25, or if we get something that's true, then we can feel more confident that we're doing this correctly. But I will leave that as an exercise so that you can practice this on your own.